In our last class, we discussed extensively on reflection, right, of light through plane mirror, isn't it so? And we define the word reflection as the bouncing back of light waves as the light hits an obstacles. When the light hits an obstacle, the light tends to reflect back, isn't it so? That's called reflection, right? And we also talked about the various types of reflection, right? We have, who can remind me? The types of reflection we discussed about. We have the scattered reflection, right? The regular reflections, the scattered reflection, isn't it so? Regular simply means that when a light ray, parallel light ray, right, incidented, or once they're incident on a smooth surface, they will reflect back as parallel ray in one direction. We call that regular reflection, right? Then we have what we call the diffuse reflection, isn't it so? Diffuse means when parallel rays hit or incidented on a rough surface, they will reflect back in different words, direction. That's called the scattered. It's also called the diffuse reflection, isn't it so? Then one thing we should know is that reflection is not only on a plane surface. We can also have reflection on curved mirrors or curved surface. And we have two types of curved surface, which I'm looking at today. We have what we call the concave and what? The convex. This is the concave. This is what? The convex. Either the concave is just like if you have a spoon, the inside of that spoon is called the concave, while the outside is called what? The convex. Either. So let's imagine it that way. That this is the inside of a spoon. Either. This is what the outside of what? Of a spoon. So this is called the concave mirror. Concave what? Mirror. This is called what? The convex what? Mirror. Are you following? So concave and convex, they have what we call the front and behind. The front is always on the left hand side. The front of the mirror is always where? On the left hand side. While the behind is what? On the right hand side. So both concave and convex have left and what? Sorry, front and what? And behind. So this is the left hand side, right? So this is called the front of the mirror. Are you following? This is called what? Behind. Behind the mirror, like the back of the mirror. For this, what will it be? Front. Are you following? What will it be? Behind. Do you get the concept? The left side is called the front. The right is called what? The behind. Is it making sense? Okay. Now we also talk about there are some certain terminologies in the mirror, in the curved mirror. And I gave us an assignment last time. We talked about what? You can remind me? The aperture, right? The aperture. What again? We have what we call the principal axis, right? The principal axis. The principal focus. The principal what? Focus. What again? The center of curvature. The center of curvature. The radius of curvature. The next one is the radius of what? Of curvature. Okay, we have the pole as well, right? The aperture is the pole. The same as the pole of what? Okay? The pole. The aperture talks about the width of the pole. The width. If I have a width here, a mirror, the width represents what? The aperture. Are you there? Okay. Then the principal axis is a line that divides the curve into two. The principal axis is a line that passes through what? The center of the mirror. Every mirror has, it is a mirror, the center is where? Is here, right? In a parabola, we call this part what? The vertex. Can you remember? So that line that passes through the vertex is called what? The principal what? Axis. Then the principal focus, this is the point in the mirror where all the light rays, all the incidental light rays, both the reflected light rays must have to what? Pass through for the image to be formed. So we have somewhere from where? The center of the curve down to this point we have what? Our F. Either. Then from this focus here we have what? Our C. Either. Just view the mirror like a circle. Like if I have a circle, are you following? You know we say in a circle that from the center to this point called the vertex. If at all, though in a mirror, in a circle there's no vertex, we're just assuming that this is a vertex. But let's say from this center to this point, you know it's called what? The radius, right? Can you remember? It's called the radius. So from the center of curvature to the mirror, either to the pole of the mirror, to this part is called what? The radius. And don't forget that from your center to your focus equals from the focus to this point here. Either. So it simply means that if from here to here is F, we have F plus what? F, right? Equals to what? Your radius. From here to here is your what? Your focus. Also your focus. From this point to here is your focus. The same distance is covered from the focus to what? The center of what? Curvature. So if I'm to add up these two, what we have 2f equals to what? R. That simply means that I can find the focus, right? My focus is what? The radius over what? Over 2. Are you following? So I'm to find the focus is simply to divide the radius of curvature by what? By 2. Is it not so? Alright. There's another thing again which is called the focal length, right? The focal length. The focal length is simply defined as the distance between the focus and what? And the mirror itself. Alright. So I think the actual word for here is called the pole, Abi. This is the pole. This is the aperture. Okay, so that's just that. Now take note of this. Take note that the object is always in front of the mirror. Please write. The object is always in front of the mirror. The object is always in front of the mirror. The object is always in front of the mirror. When the object is placed in front of the mirror, when the object is placed in front of the mirror, DO, which is also your U, is what? Is positive. DO, which is also your what? Your U is what? Is positive. Where DO, which is U, is equals to what? The object what? The object distance, right? The object distance is what? Is positive. Then the next is the image DI equals to V is positive also in front of the mirror. The image DI equals to V is also positive in front of what? Front of the mirror. Front of the mirror. In front of the mirror. What is the front of this concave mirror? This, Abi. What the front here? This. What I'm giving you is for both concave and what? Convex. If the object is in front of this mirror here, it's positive. The front of the convex mirror is what? Is here, right? What is the back? Is here. That means this is the reflecting surface. For this is what? The reflecting what? Surface. Are you getting the gist here? If the image is behind the mirror, number 3, guys. If the image is behind the mirror, DI is negative. If the image is behind the mirror, DI is what? Is negative. Is that true? Is that true? If the image, if the what? Image is behind what? The mirror. That means the image form is what is negative. Because why? The image is where? Behind the mirror. Do you get the concept? And what condition are we going to have for we to have a negative image? Is when the object is placed between the focus and what? And the pole. Now I said it. For this diagram, if I place any object here, it will form the image behind what? The what? The mirror. Any image formed behind here is what? Is negative. Now right, put this down. Note that when DI is positive, that is just in this form, when DI is what? Is positive, the image is what? Is real. Image is real. But when DI is negative, the image is what? Is virtual. Virtual image and negative image. Whenever DI is positive, the image is real. When DI is negative, image is what? Is virtual. Who can tell me one striking difference between concave mirror and convex mirror? Okay. Okay. Yeah, correct. I was even thinking you talk about in terms of the rays of light. Concave mirror converge. I remember. They converge what? Rays of light into focus. Why convex does what? Diverge. One of the striking difference between concave mirror and what? Convex. But when it comes to lens, it becomes the reverse. In lens, concave lens diverge, while convex lens converge. Are you following? That's the difference. So just take note of this. That is just a remarkable, well, it's a more remarkable difference between concave mirror and what convex what mirror. Use that explanation to differentiate them. Okay. Also, write that, note that the focal length for a concave mirror is positive. The focal length for a concave mirror is positive, while the focal length for a convex mirror is what? Negative. Take note of this. We have what we call the mirror formula, right? Mirror formula is simply 1 over what? F, right? Equals to what? 1 over V plus what? 1 over U. Are you aware? Where V represents what? The image distance, Abi? What's your U? The object what? Distance. Subheading, magnification of mirror. I want to say magnification, please write. Magnification, yes, magnification is actually used to compare the magnitude of image produced with that of the object. It's about how large the image is as compared to what? To the object. How large the image is as compared to what? The object. If the image is reduced or is enlarged, are you following? As compared to what? How large the image is as compared to the object. Do you get the concept? You know, when you place the object, it is the object that produces what? The image. So the image can either reduce or what? Or enlarge. So the comparison between the image height or the image height, whether it reduced or it enlarged, as that of what? The object is called what? Magnification. Do you get the concept? So the formula for that is actually M is equals to what? HI divided by what? HO, which is also equals to what? DI over what? DO. In fact, minus DI over DO. Magnification is defined as what? HI over what? HO equals what? Minus DI over what? DO. This is the general formula for magnification. HI represents what? The height of the image, Abi. What's the HO? The height of the object. What's the DI? Distance of the image. This can also be what? Minus V, right? Over what? Somebody? Over U. Don't forget. Your distance, DI, represents your V, right? While your DO represents your what? Your U. Are you there? Please note that for your magnification, okay? If magnification is actually positive, right? Are you there? The image is upright. Image is what? Upright. If magnification is negative, the image is what? Is inverted. Is what? Is inverted. You know, we can have upright image and what? Inverted image. When the absolute value of your magnification is greater than 1, eh? The image is enlarged. Is what? Enlarged. Meaning it is taller and bigger in size than what? The object. Are you following? Absolute value of your magnification, meaning that even though it's negative or positive, you must take it as well positive. When they say, what is the absolute value of minus 2? What's the answer? It's 2. Do you get it? What's the absolute value of 2? It's still what? It's still 2. Meaning this value must be what? Positive. So when the absolute value of your magnification is what? Greater than 1, that means the image is what? Enlarged. Are you there? When the same absolute value of magnification is less than 1, it means what? The image is what? Diminished. You know, image can either be enlarged or what? Diminished. That means smaller in size as compared to what? The object, right? When the absolute value of magnification is now equals to 1, what do you think will happen here? If the image is enlarged, if it's diminished, can also be what? Equal with the object. And that equal is what? When your n is equals to 1. So the image is what? Is same size, Abi, as what? As the object. But don't forget, at what point do you think we achieve this? You can tell me. Now the image is the same size as the object. At what point? Is when the object is placed where? Yes, it's where? At the center of the curvature. That means that when the object is where? At this point, Abi, that means the image form will be what? The same size as what? The object. Are you following? If they'll be at the same point and they'll be the same size. So at that point, we are saying that our M is what? Somebody is equal to 1. Is it clear? Okay. Okay, let me ask this question. If magnification we say is what? HI over what? H4. Is it not so? If the height of the object, let's say the height is 4, and the object's height is what? Let's say it's 2. What do we have here? We have 2 abi. Is 2 greater than 1? If it's greater than 1, that means that what happened? The image is what? Is enlarged. Is it not so? And it's true because the height of the image is more than what? The object. But if the reverse is the case, that means what? The image is what? Diminished. Is it clear now? So don't forget, please, okay? And don't forget that it must be what? Absolute what? Value. Example 1, right? If a concave mirror of focal length 8 centimeter and an object is placed 20 centimeter away from the mirror, if the height of the image is 4 centimeter, right? Determine number 1, the location of the image. Number 2, how tall is the image. Number 3, what is the magnification of the image? Number 4, determine if we have a real or virtual image. Number what again? Number 5, is the image upright or inverted? Is the image enlarged or diminished, right? Okay, now let's solve. We are told that we have a concave mirror. Now already we should know the focal length of what? Concave mirror is what? Plus, abi, is positive. Don't forget. Focal length. Is it your note? Focal length of all concave mirror is what? Is positive. Is it your note? If it's not there, please add it to it. The focal length of all concave mirror is what? Positive. Is there, ba? Okay. Now let's list out. Is negative here. Let's list out all the stuff we have. If a concave mirror of focal length, what's the focal length here? 8 what? Centimeter. So we know it's positive, right? We convert to meter here. Okay, they are all in centimeter. No, don't convert to meter. Just work that way. Okay. Okay, let's go. What's the focal length? 8 centimeter. Object distance, right? What's the object distance? U, right? Is what? 20 what? Centimeter. Are you following? Okay, what again? The height of the image is given as what? 4 centimeter. What's the height? Is 4 centimeter. What again? Determine the location of the image. That means determine the distance of the image. Location means at what point is the image located from the pole. Is it not so? Are you following? Okay, so what do? We use our mirror formula, right? Use the mirror formula. What's the mirror formula it gave us? 1 over F equals to what? 1 over what? V plus what? 1 over U. So we have 1 over what's the F? 8 equals 1 over what? What's the V? V is what? Is V. Thank you. We're looking for V, right? Plus what? 1 over 20. Are you there? So the next is to move this to the other side, right? Are you there? Or we subtract 1 over 20 from both sides. Is it not? And that will give us what? 1 over V equals what? 1 over 8 minus 1 over 20. So we have 1 over V equals, what's the SN between 8 and 20? We have 40. Is it not? So divide 40 by 8. What do we have? 5. 5 times 1 is what? Is 5. Minus, divide 40 by 20. What do you have? 2. 2 times 1 is what? Is 2. So what do you have? We have 1 over V. 1 over V equals what? 3 over 40. Can we cross multiply? We cross multiply. That means what? 3V equals to what? 40, right? So V becomes what? 40 over what? 3. And what do you have for V? 13.3 cm. Are you following? So the question says what? Location of the image. You can tell me the answer. It is 13.33 centimeter, right? Away from what? The pole of the mirror. Are you getting this? Then the next one is what? Yes? Your V represents the image distance. Your U represents the object distance. Are you getting this? Then number 2 says what? Yes, it's at the front of the mirror, not at the back. Why is at the front of the mirror? It's positive in value. Whenever your object distance is positive, that means whenever your image distance is what? Positive, that means the image is where? In front of us, the mirror. But if I have negative, that means it is behind or at the back of the mirror. Okay. Number 2 says what? How tall is the image? We are told already. We don't need to. Okay, we are asked for how tall is the mirror. is the image, right? Okay, that is our image height. Is it also the height of the image? We are told is what? 4, right? Are you getting it? Height. Magnification is given. It's not given. And we are told that the height is already 4 centimeters. And they say find the height again. That's a contradiction. Okay. I mean, if there's no height. Okay, how tall is the object? if you are not asked to find how tall is the object, okay, well, that would be what? HIRB over what? HO. I'm to find this, right? Okay. Yes. Don't forget that we say this is also equal to what? Minus DI over what? DO. We already have this, Abi. We also have this. Isn't it also? Eh? Image distance over what? Object distance. Or we can say minus what? V over what? You Abi? So if you can get this will give us what? The magnification now. Yes. So what you do is to cross multiply, right? Yes.
I'm not saying that you like how this
Mm.
you is also what
U. Yes, now U is same as your. No, I'm not saying U is equal to HO. Your HO is the height of the object. The height. Eh? Your U is what? The distance of the object from the pole of the mirror. Not the same number now. Okay, let me show you now. What's our V? Your M, I see it is what? Minus what? DIRB over what? DO. This is your note bar. And that will give us what? What do you have here? Now 13 point what? 33, right? Over what? What's our DO? Huh? 20. And what do we have? Give me the value. Give me the value. 0.6665, Abi? Centimeter, right? Then also recall that magnification is what? HI, Abi? Over what? HO. Is it not? And that will give us what? This is equal to what now? Minus what? 0. What? 66 what? 65, Abi? This over 1. Is it not so? And we have to find what? You're looking for the H what? HO. Is it H you're looking for? We have HI as what? 4. So I will just cross multiply. This is 4, Abi? Over HO. That will give us 4 is equal to what? Minus 0.6665 times what? Times what? HO, Abi? Then my HO becomes what? 4 over what? Minus what? 0.6665. Yes. The image distance. This is it now. This is your V now. You know I say your V represents your image distance. Take your notes now. Your V is same as your what? Your DI. Your U is same as what? Your DO. Not equal to HI. Don't see your H as height. See your D as distance. Is it clear? Okay. Which one? What are we asked to find, number 2? How tall is the image? No, object. This is object now. We are only giving how tall the image is, which is what? 4 centimeters. That means the height of the object. And I said, I say find how tall is the object. It means I have to find this, which is what? Let's divide. Let's go. Minus 6.00115. So this, let me say minus 6.00, 6 either. So that means the height of the object is what? Is 6.00. Just neglect it. Number 3. Number 3 says what? Yes, number 3 says find the what? The magnification. Magnification. What do we say the formula? M equals what? Minus DI over what? DO or what? HI over what? HO. So which one will I use? We only have HI, we don't have HO. Then I will not use this, right? So let's go. Do you get the gist now? So what's that M? Minus what's that DI? What's that DI? Our distance is what? This is what? 13.33, right? We have 13.33. What's that DO? 20, right? DO is 20. So when you divide, what do you have? 0.6665. Are you sure? Okay. Huh? Is that? Yes, 65. Okay. You see what? Okay. I'm coming. I'm taking something. 1/8, 1/2. I didn't get you. Let me get.
Before this is minus
Yes, what happened? And we have to find what? It's an easy formula to solve, but anything you're having, make sure your answer is what? Positive. Do you understand? Just take the absolute value of that stuff. Okay. Are you there? What's the next one? If we have what? Now, from the question, from what we have seen so far, is the image real or virtual? Is real. Why is it real? It's positive, Abi. What's the image distance? 13.33. So the image is real, right? What's the next one again? Is the image upright or inverted? How do you know that? I gave a formula for that. I said when magnification is greater than, right? Is it not? Read for me. Upright, okay? Is inverted, good. So for this, we say that, we recall that, we say when magnification is what? Negative, right? What's the image form? What's the image form? Inverted, right? Good. But when magnification is what? Positive, right? What's the image form? Huh? Inverted and what? Is upright, Abi. Do you get the gist? When your M is negative, image is what? Inverted. When M is positive, image is what? Is upright. So for this, our M, since magnification is what? Is negative. That means the image is what? Image is what? Inverted. Image is what? Inverted. Please write. Do you know, and listen, stop writing, pay attention. There are so many textbooks that will tell you that your M, in fact, I was also a victim of this, that M is what? Is V over what? U, Abi? Which is same as what? Your DI over what? DO. Are you saying the gist now? If I'm to use this formula to solve this now, it means here becomes what? Positive. So I'm going to be saying that the image is what? Is what? Upright, which is wrong. Very wrong, because if I'm to consult this diagram now, you will see by yourself that the image is what? Is inverted. Because the image will be formed in front of what? Of the mirror. Any image formed in front of the mirror is what? Is inverted and is real. Are you following? When you have a curved mirror, have you ever imagined a curved mirror before? Have you seen a curved mirror before? To look as though the image is always inverted. That one is a concave word mirror. Do you get this? So if I'm to use it direct, I will end up failing it. It took me time to discover this formula. Minus d over what? Do. But if I'm to solve for my distance, let's say I'm giving M, and say find your distance, your di. I will see this formula, but at the end of the day, because distance cannot be negative now, in a curved mirror, we don't have negative side and positive side. So anything you have is always what? Positive. But if I'm to find the magnification, I have to use what? Minus di over what? Do. And that will tell us the nature of the image, if it's what? Inverted or what? Upright. Now from here, we saw that our M is what? Negative. That means the image is what? Inverted. Now the next one says, is the image what? Enlarged or diminished? Who can tell me the answer? Why is it diminished? Is it less than 1? Yes. Is it less than 1? Now let's look at number 4, right? Number 6 rather. Says, is the image what? Enlarged or diminished, right? Don't forget that we say that if your absolute value of your what? Magnification is greater than 1, is it not? The image is what? Enlarged, Abi? But if your absolute value of magnification is less than 1, what's the image? Image is what? Diminished, right? Diminished. Now what happened here is that since magnification absolute value is less than 1, is it true? This value is less than 1. If I'm to take the absolute value of minus 0.6665, what will it be? 0.6665. And this value is less than 1. Since it's less than 1, that means our image, therefore, The image, Abby, is what somebody is diminished. The image is diminished. I want us to analyze something. Let's see if truly the image is what diminished. And if it is also what inverted. Are you there? You know, we say our m is what negative, so the image is inverted, and it's also diminished because m is less than what 1. Is it not so? Look at this diagram. Please pay attention. What's our focus there? Focus is what? 8, Abby. From here to here is what is 8, right? This is my focus. From the focus to here is also what? Should be also 8, right? This is my center of curvature, right? Right there. So our radius is about 16, okay, centimeter. So now let's watch. Our object distance is 20. Your U represents your what? Your DI, Abby. Your V represents your what? Sorry, your U represents your what? Your DO. What's the V? Your DI, right? Okay, now let's watch. Let's bring out the object, because the object that forms what? The image. What's the object? 20. So the object is 20. If from here to here is what? 16. 16, right? That means 20 should be somewhere. Yeah, let me say, here is also, this 8, Abby. 8, 24, right? Between this, Abby, halfway. The object is here. This is our object. Now, whenever parallel rays of light comes from here, are you following? It must reflect back and pass towards the focus. Reflect back and pass to the focus, right? Now, under rays of light coming from the object itself, from the object, we also pass towards the focus, right? We pass to this focus. Are you seeing it? From this region, it's coming from here. When they pass to this focus, what do you think will happen? It will reflect back as parallel ray, right? And meet with what? With the first line. This is the first line, Abby. This is the second one. Are you following? So they will intersect at a point here. So this is where the object, the image rather, is formed. But I said that any image formed in front is always what? Inverted. Abby? What do you notice here? The image distance is between what? C and F. Is it not? What's the image distance? 13.333. And from here to here is what? 8. Here is what? That means 13.3 is still between what? Between your center of curvature and what? And the that means this answer is what is correct. Is it making sense here? So, but if I'm to draw this using my normal compass, you will see the exact thing. You know, the compass you will draw, then measure it to a ruler, right? Is it not so? You can try that as your assignments. Get your compass, draw a straight line, measure the distance of the object distance, then trace it, you will get the answer. No, you don't need to draw this in the exam. I'm just showing you that we can also represent this to see that the answer is correct. But what do you notice here? Is the image diminished or enlarged? It's smaller than the object. Is it not smaller than the object? Are you seeing the height? If I'm to construct this using my normal compass, you will see the size very small as compared to what? The object. Do you get? Number what? Number 2. Next question, yes. Are you ready? A tree stands 1 meter. A tree stands 1 meter from a concave mirror. A tree stands 1 meter from a concave what? Mirror. With a radius of curvature. With a radius of curvature 20 centimeter. Are you there? Yes. 20 centimeter. Find, number 1, the position of the image. Number 2, find the magnification, position of the image. Number 1. Number 2 is what? Find the magnification. Number 3, what is the nature of the image? What is the nature of the image? Nature of the image, yes. You know what I say nature, you know what it means, Abi? Is the image upright or inverted? Is it enlarged or reduced? Is it real or what? Virtual. That's the nature. Everything comprises in your words. Nature. Do you get the concept? A tree stands 1 meter from the concave mirror, right? Now, we already told that it's a concave mirror, so we should know the image form is what is real. Isn't it so? And what's the focal length? What's the focal length? Is positive. Because the concave what? Mirror. So the 3 stands 1 meter, right? What is the 3? The objects. It means my distance, my DO is what? 1 meter, which is same as what? 100 what? Centimeter. Are you aware? Okay. Then, yes. Always use, just use your CM when it comes to mirror formula. Mirror. Anything mirror calculation, use your CM. Are you getting this? Because if you take your ruler is in what? Centimeter. Are you following? So we use the ruler to measure that. Use your what? Your CM. So we are told that a tree stands 1 meter from a concave mirror, meaning that 100 centimeters from a concave mirror. With radius of curvature, what's the radius of curvature? 20 centimeters. I see that they already converted this to what? 20 cm already, right? Now we have to find the position of the image. Now when I say find the position, that means what? Where is the image located, right? A distance. So remember, okay, there's a formula they didn't give us. Please note this, that you know we say 1 over f is equals to what? 1 over what? VRB plus what? 1 over u. And don't forget that your f is what? R over what? 2RB. Are you aware of this? So if I'm to put this value here, this can also be what? 2 over what? R. 1 over f. 1 over the inverse of this. So if I say 1 over this becomes what? The inverse of this, which is 2 over R equals to what? 1 over what? V plus what? 1 over what? U. Are you getting the gist now? So I can also use it to solve, right? Or can I swear find what first? Your focus. So which one do you want? Let's find focus first, right? Okay. So recall that focus is what? R over 2. And that will give us 20 divided by what? 2. What do you have there? 10 centimeters, right? Are you following? Then we say recall that the mirror formula says 1 over f equals what? 1 over v plus 1 over u. Can also be 1 over u plus 1 over what? V. Okay? Anyhow they put it, you see the same thing. This plus this, same as this plus this. Are you following? So we have 1 over, what's that f there? What's that f there? 10 equals 1 over what? What's that v? V is what? We're looking for v, right? Okay. So 1 over 10 equals 1 over v plus 1 over our u is what? 100. Now what do we say we're going to do here? 1 over v, we collect like times b. We subtract 1 over 100 from both sides. And that will be what? 1 over v equals what? 1 over 10 minus 1 over what? 100. So 1 over v will give us what? What's the sum between 10 and 100? Is 100, right? Divide 100 by 10, what do you have? 10 times 1 is 10. Minus. Divide 100 by 100, what do you have? Times 1, we have 1. So that implies what? Let me use this small space. That means 1 over v equals what? 9 over what? 100. So I'll cross multiply, right? That will give us 9v equals what? 100. So v becomes what? 100 over 9. What's that v when you divide? Please divide for me. 11.11 what? cm. Are you following? Okay. Now we know the position. Yes. And the position simply means where is the image located from the pole of the mirror. Do you get? Like for example now, like we gave, if here is object, let's say this is position of what? Of the object. This is my DO. If the image is somewhere here, this is what? My DI. So position means where is the object located, or where is the image located. So when there's a position of the image, it means that no, the distance of the mirror. Is that what I say? Position of what? Of the image. Yes, of the image from the mirror. Either of the image from the mirror. Do you get? It's an image distance. Do you get this? But don't forget that we use DI to be what? Your V. What's your DO? Your U. Don't forget, okay? So where are we? So what is the position of the image from the mirror? It is 11.11 cm away from what? The pole of the mirror. Are you getting the gist? Now we have to find what again now? Magnification. 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 Formula says what? M, right? Equals to what? Minus DI over what? DO, right? and is equals to what? Minus what? V rather? No. HI over what? HO. Is it not? Okay, then this one. This is also V, yes, you are aware. But just bring out these two, is okay, okay? Okay, I can also say, okay, let me just bring it out. Minus VRB over what U. Now let's put the values we have. So M becomes what? Minus VI. Minus what? 11 point what? 11 over what? Over 100. What do we have? Minus 0 point what? 1111. This way, right? Okay. There's no units for what? Multiplication. You know why? It's the ratio of two distance. So CM will cancel what? CM. Do you get the gist? This is like saying CM over what? CM. So the word cancel out, right? Okay. So the question says the nature, right? From what we have learned now, the nature. What do we say the nature? What's the first nature we're looking at? Is it real or virtual? It's real. Why is it real? Because the image is positive. Do you get the concept? And it's also real because we are considering what? A concave what? Mirror. Any image form in the concave mirror is what? Is a real image. Are you there? Okay, now the nature. The nature, what is the first nature we're looking at? Number one is that it is real. Because the image is real and because we are talking about a concave what? Mirror, right? Number two is what? Okay, how do we know diminish? We say that, look at this. One, our magnification is what here? Is negative, right? And what does that mean? Okay, since our M is negative, that simply means that the image is what? Image is what? Inverted. Please don't forget, okay? Let's check this also. The absolute value of our magnification, I guess, is what? 0 point what? 11, abi? This is less than 1, right? Since it's less than 1, what happened? The image is also what? Diminished. Is diminished. We say that when your magnification is negative, the image is inverted, but when the absolute value of your what? Magnification is less than 1, the image is what? Diminished. This is the same thing with the first one, right? The same thing, right? But just that they have different figures. Alright, guys. So the next question here says that how far should an object be from a concave spherical mirror of radius 36 centimeter to form a real image 1/9 of each size? We are also find how far should an object be. Okay, we are given that our radius is 36 centimeter. Okay, to form a real image, which is 1/9 of each size. Okay, now we are told that our magnification is 1 over what? Over 9. Our M is 1 over 9. And we also find how far should an object be placed. So we are looking for the object distance, right? The object distance. So we are given our M to be 1 over 9, which is our magnification. And we have to find the object what? Object distance. But recall that we say that magnification is equals to the image over what? The object, which is same as our di over what? Do, right? So that means from here we have 1 over 9 equals v over u. I can cross multiply this. That will give us u is equals to 9v. So the value of v then becomes u over what? 9, which is same as v equals 1/9 of the object. So what the statement actually means is that we are told that how far should an object be from a concave mirror of radius 36 centimeter to form a real image 1/9 of its size. So the real image form should be 1 over 9 of the size of the object. So it's either you go through this process to get the value of the image, or you can just multiply 1 over 9 with the object. That will give us the size of what? Of the image. But the question says the distance. We are looking for the distance of the object from the concave mirror. Okay, for me to find the distance of the object from the concave mirror, we have to find our focus, right? Then recall that focus equals to r over 2, right? So this implies that the value of r is given as 36 divided by 2. So when we divide this, we will have 18 centimeter. So the focal length is actually 18 centimeter. But the question says, find the distance of the object from the concave mirror? How far should an object be from a concave mirror? Then we are going to use our mirror formula, the mirror formula that we spoke about this morning, that we say that 1 over f equals to 1 over u plus 1 over v. So from here we have 1 over, our f is actually 18, is equals to 1 over u plus 1 over. The value of our v is given as u over 9, or 1/9 of the image. I can use this to substitute the value of v, which is u divided by 9. So here we have 1 over 18 is equals to 1 over u plus 9 over u. If I'm to solve this simply means inverse, right? 1 over u over 9 simply means inverse of this. So that will give us 9 over u. So we have 1 over 18 equals, the LCM between these two is u. U divided by u is 1. 1 times 1 is 1. U divided by u is 1. 1 times 9 is what? Is 9. So we have 1 over 18 equals to 1 plus 9 is 10 over u. So what are we going to do next? Is to cross multiply. We cross multiply to find the object distance. So u times 1 is actually u equals to 10 times 18. That will give us 180 centimeter. So the object is 180 centimeter away from the concave mirror. Okay, the next question says that from the mirror formula, determine where the object must be placed if the image is to be the same size as the object. For what I told us this early morning, whenever the image and the object are of the same size in a concave mirror, or in a mirror rather, that simply means that the distance of the object from the pole is same as the distance of the image from the pole. It simply means that both the object and the image lies at the center of what? Of curvature. Please don't forget. Alright? So we have that from the mirror formula, determine where the object must be placed if the image is to be same size as the object. Now let me explain this using a diagram. If I have a diagram like this, and we have this, we say from this pole to this focus is equals from the focus to the center of curvature. And we say whenever an object is placed here, the image form will also be beneath, right? And we say that the height of the object and the height of the image are the same. That implies that the distance of the object from the pole is same as the distance of the object from the what? Of the image rather, from the same pole. Question says from the mirror formula, that means where the object must be placed if the image is to be the same size as the object. Don't forget that your distance of the image distance must be equal to what? Object what? Distance. We have to find where the object must be placed if the image is to be the same size as the object. Okay, very simple. If the image is to be the same size as the object, that means that the object distance must be equal to the image what? Distance. Then from the mirror formula, 1 over f equals 1 over u plus what? 1 over v. Meaning 1 over f then becomes what? 1 over u plus 1 over u. Meaning our v is equal to u. Means I will replace v with what? With u. Because the question says we have to find it to determine where the object must be placed. That means I have to replace my v with what? With u. So we have 1 over f becomes 1. The LCM between these two is what? Is u. Divide u by u, we have 1. 1 times 1 is 1. Divide u by u, we have 1. 1 times 1 is also 1. So we have 1 over f equals to what? 2 over what? U. And that implies that by the time we cross multiply, that means we have 2f equals to what? To u. Therefore, the object will be twice the what? The focal length. And it's true. Therefore, we say that if we have the object is here and the image is also here. So the object is twice the focal length because from this pole to this region is what? Our f, Abi. The same distance is covered from f to what? To the center of curvature. Don't forget that we say that from here to here is actually what? Is actually r. Is it not? So if here is r, that means here will be what? F. Here will be what? F, Abi. So f plus f equals to what? R, which is what? 2f equals to r, right? So that implies that the object here, any object here, right, is actually twice what? A focal length. Because from here to here is what? Is 2f. Don't forget that from this region here to the pole is what? Is 2f. So that means the object is what? Is 2f. Now we have seen that from the mirror formula, we also discovered that the object distance is also what? 2 times the focal length. Okay, the next question says that where must an object be placed with respect to a convex mirror with focal length of 25 in order to obtain an image to third as far behind the mirror as the object is in front? I repeat again, where must an object be placed with respect to a convex mirror with a focal length? Now we're giving our focal length to be 25 centimeter. Now because we are told that the mirror is a convex mirror, that means we're going to have negative focal length. Don't forget that every mirror, every convex mirror have a negative focal length, while every concave mirror have a positive focal length. So we are told that the mirror is a convex mirror. The focal length is 25, which is negative 25, right? Okay. We are now said, where must an object be placed in? Okay. So the question says, where must an object be placed with respect to a convex mirror with a focal length of this, right? In order to obtain an image, the image obtained is to third the object. In order to obtain an image to third as far behind the object as the object is in front. That means that the image obtained is to third the object. And don't forget that since it is a convex mirror, the image form will also be what? Negative. The image is also negative. So focal length is negative, image is also what? Negative. Then let's find the object. The object distance is what we are looking for. Then using the mirror formula says 1 over f equals 1 over u plus 1 over v, or 1 over v plus 1 over u. Anyone, you are still correct. So let's go. We now have 1 over what? Minus 25 equals to 1 over u plus 1 over, our v is negative 2/3. It means 2u over what? 3. This is same as minus 2u divided by 3, right? Okay. So let's evaluate this further. This will give us 1 over minus 25 equals to 1 over u. Minus times plus is minus. Inverse of 2/3 will give us what? That will give us minus 3 divided by what? 2u. Okay, the inverse of this simply means 3 over 2u, right? Okay, so our formula, our expression rather becomes minus 1 over 25 will be equals to, the SN between these two will be 2u. Divide 2u by u, we have 2. 2 times 1 is what? Is 2. Minus, divide 2u by 2u, we have 1. 1 times 3 will give us what? 3. So we have minus 1 over 25 equals to minus 1 divided by what? 2u, right? So from here we can cross multiply. That will give us what? Minus 1 times 25 is minus 25 equals to minus 1 times 2u is what? Minus 2u. Then our aim is to find the object, which is our u. So we divide both sides by minus 2. That will give us minus 25 over minus 2 equals to minus 2u over what? Minus 2. So this can go with this. Minus can cancel minus. 2 here 1, 2 in 25, that should be about 12.5, right? Okay, so therefore our object distance is 12.5 what? Centimeter. All right, let's look at the next question. All right, the next question here says that a concave mirror of radius of curvature 20 centimeter produces an inverted image. The concave mirror, our radius is given as 20 centimeter, right? Okay, from here we can look for our focus, which is r over 2. Then we have 20 divided by what? 2, and that will give us 10 centimeter, right? Okay, produces an inverted image. The image we are told is 3 times the size of an object. The image is 3 times, the image form is 3 times the size of the object, which is 3 times u, all right? Then we have to calculate the position of the object and the image. The image position, which is u, and also the object position, right? Now, recall the mirror formula says 1 over f equals 1 over u plus 1 over v, right? We can as well use this formula knowing that f equals to r over 2. So the inverse of f becomes 2 over r equals to 1 over u plus 1 over v, right? But let's go ahead and solve with this. We can either use this to solve, knowing that the radius is 10. So it's 20 rather. This knowing that our focal length is what? Is 10. So if I'm to solve with this, it means I'll use what? 1 over 10, right? So we have 1 over 10 equals to 1 over u plus 1 over our v is given as 3u. Okay. Now the next thing we need to do is to find the LCM between 3u and u. The LCM between 3u and u, we have 1 over 10 equals, the LCM is 3u, right? So divide 3u by u, we have 3. 3 times 1 is 3. Plus divide 3u by 3u, we have 1. Okay, 1 times 1 is give us what? 1. So we have 1 over 10 equals to 4 over what? 3u. So here, let's cross multiply. This will give us 10 times 4 is 40 equals to what? 3u. So our u becomes 40 divided by what? 3. Therefore, our u should be about 13.33 centimeter, right? 13.33 centimeter. Okay, this is our value of u. We have gotten our u as 13.33 centimeter. Then the next one says, find your what? Your v. We have to find the image distance as well. The image distance is going to be v equals to what? 3u, right? So that will give us v equals to 3 multiplied by our u, which is 13.33. So v should be about 40 centimeter. Our v is 40 centimeter. Of course, even from here, 3u equals to what? 40. And what's that 3 representing? Our v. So I can compare this with this. That means my v is what? 40 centimeter. Or I can multiply the value of my 3 with the value of u, which is 40 centimeter as well. Alright? Okay, the next question. Okay, look at this question. Question says that at what distance must a dentist place a concave mirror from a tooth? At what distance must a dentist, meaning we are looking for our u, at what distance must a dentist place a concave mirror from a tooth if she wishes to observe the tooth magnified fourfold? At what distance must a dentist place a concave mirror from a tooth? So that means the distance from the concave mirror to the tooth. The tooth represents the object. So I'm looking for the object distance, not the image. So many students fail this question, and the question came out some certain way like that. Many of them fail. They are looking for the object, the image distance. Question says, at what distance must a dentist place a concave mirror from a tooth? That means the tooth distance from the concave mirror is we have to find the image distance, right? If she wishes to observe the tooth magnified fourfold, that means that if the tooth is to magnify fourfold, that means the image is 4 times the object, right? Let's look at this again. At what distance must a dentist place a concave mirror? The mirror is concave, that means the image from the focal length is positive, right? Okay. From a tooth, if she wishes to observe the tooth magnified fourfold. Now we are told that magnification is 4. Recall that we said that our n is equals to what? V over what? U. The whole of this is equals to what? 4. That means that our image form should be what? 4 times what? The object. Don't forget this formula, this expression. Okay? Or we can just go ahead and say our V equals to what? 4 times what? U. Like we saw in the previous example, right? Okay. Now recall the mirror formula says that what? Recall from our formula we have that 1 over what? F is equals to 1 over what? U plus 1 over V. So we have 1 over F equals to 1 over U plus 1 over our V is 4U. Alright? So by the time we solve for that, we have 1 over F equals to 1, okay, no, equals to the LCM between U and 4U is actually 4U. So divide this 4U by U, we have 4. 4 times 1 is 4. Plus, divide the 4U by 4U, we have what? 1. 1 times 1 is 1. So that means our 1 over F becomes what? 5 divided by what? 4U. Don't forget our aim is to find the object distance. Okay? So we're going to cross multiply. We cross multiply. That means 5F is equals to what? 4U. Then we divide both sides by what? By 4. That will give us over 4 over what? 4. 4 can go with 4. Therefore, our object distance is actually 5F divided by what? 4. Okay, this is the formula, the answer rather. This is the answer we are looking for. This is the answer we are looking for. That means the object distance is 5f/4. Then if we are not given the focal length, okay, of that mirror, we can put the value there, multiply by 5 to get the actual value of the object distance. All right, guys, thank you so much. I really appreciate you guys for watching. I want you guys to do me a favor. Please ensure you like this video, ensure you comment if you can, and ensure you subscribe. And lastly, ensure you share this video to your friends in other schools. This is a general topic for all students in year 1 in different universities. Okay, please make sure you share. Let's be a blessing to others. My name remains EMI-BRAIN. Thank you.